I'm David Toman, author of NootropicsExpert.com, and in this video I'm going to share with you the best nootropics for learning and memory. Memory is fundamental to quality of life, something as simple as remembering where you left the keys, to the recall required for your next exam or board presentation. Science has now discovered not only how memory works in our brain all the way down to the molecular level, but has also empowered us as neurohackers to be able to select the best nootropics for improving learning and memory. Once you understand, even on a basic level, how memory works in your brain and the different mechanisms affecting it, you can confidently build a stack that works. Now, I encourage you to watch this entire video so you're confident that it isn't magic. We have real science and years of practical experience on boosting memory with nootropic supplements. Now, it's a long video, so after you watch the entire video, you can go back and you can skip through to individual segments by using the table of contents that's below this video. It's got timestamps on it. You click on the timestamp and you can jump ahead to that part of the video. Let's get started. A new memory typically involves interactions between thousands of neurons. If this new encoding doesn't get used, it will soon fade. But when you continue to reactivate the information that you've stored by rereading this sentence, if you're reading the transcript of this video, then the connections become reinforced. Or if you watch this segment of the video over and over again, you reactivate this information that you've stored by listening to this video over and over again, and the connections become reinforced. There are tiny physical changes going on in your brain at this moment as you're listening to this. And several parts of your brain are involved in this process of memory encoding and storage, particularly your cerebral cortex and hippocampus. In May 2016, researchers at the University of Bonn identified the mechanism of action behind memory switching from recall to memorization mode. Every new sensation you experience, including taste, sound, and sight, first enters your hippocampus. This seahorse-shaped section deep in your brain also retrieves stored information from deep within your memory. The hippocampus controls the flow of information to and from your brain. It's like memory mission control. Hippocampal astrocyte cells ensure new information is given priority. When your hippocampus switches your brain into memorization mode, already stored memories must wait. Now, in your hippocampus, acetylcholine stimulates astrocyte cells, which then are induced to release the neurotransmitter glutamate. The released glutamate then activates inhibitory neurons, which inhibit pathways mediating the retrieval of memories. This process in your hippocampus is one of the reasons acetylcholine helps boost memory. As a nootropic, we use choline supplement precursors to produce acetylcholine, including we can use choline citrate, CDP-Choline, centrophenoxine, and alpha-GPC. My favorites are CDP-Choline and alpha-GPC. The astrocyte cell discovery about memory prioritization published in the journal Neuron is particularly significant because astrocytes are glial cells, making up at least half of your brain cells. Glial cells were once thought to simply provide support for neurons. Now, this is where the idea that we only use 10% of our brain, where it comes from. Glial is derived from the Greek word for glue, or glia, and make up the white matter in your brain. Types of glial cells include astrocytes, ependymal cells, microglia, Schwann cells, and oligodendrocytes. Recent research shows that glial cells in your hippocampus and cerebellum participate in synaptic transmission, regulate the clearance of neurotransmitters from the synaptic cleft, preventing glutamate toxicity, and release gliotransmitters like ATP, which modulates synaptic function. Astrocytes are star-shaped glial cells that link neurons to their blood supply in your brain and help form the blood-brain barrier. And astrocytes regulate the expansion and contraction of blood vessels. Clearly, astrocytes are crucial to cerebral circulation or brain blood flow. Astrocytes also help provide nutrients to neurons in your brain and play a role in the repair and scarring process in your brain and spinal cord following traumatic injury. Vinpocetine, Bacopa Monnieri, ginkgo biloba, and pine bark extract are the most used nootropics to increase blood flow to and throughout your brain. Oligodendrocytes are the glial cells that help produce the myelin sheath coating axons in your brain. This myelin sheath is like wrapping a wire in electrical tape. It provides protection and allows electrical signals, or action potentials, to be more efficient, which plays a critical role in memory encoding and retrieval. Myelination generally proceeds in a wave from the back of the cerebral cortex, or the lower back of your skull, to the front, or right behind your forehead, as you grow into adulthood. The frontal lobes are the last places where myelination occurs. These regions are responsible for a higher level of reasoning, planning, and judgment, skills that come with experience. Teenagers typically have less forebrain myelin, and is one reason why teenagers do not have adult decision-making abilities. So keep this in mind the next time your teenager makes a particularly dumb decision. Piano virtuoso and associate professor Fredrik Ullén at the Stockholm Brain Institute used diffusion tensor imaging, brain scanning technology, to look at the brains of professional pianists. Professor Ullén found that professional pianists had more highly developed white matter regions in their brain compared to non-musicians. These regions connect parts of the cerebral cortex that are crucial for coordinating movement of the fingers with areas involving other cognitive processes that operate when making music. The more these musicians practiced over time, their white matter increased because their axons were more heavily myelinated or tightly packed. This study shows that when learning a complex skill, there are noticeable changes in white matter in your brain. To help produce this critical myelin sheath for your brain's axons, you can use sibutramine, vitamin B1 or thiamine, SAM-E, vitamin B12 or methylcobalamin, and vitamin B9 or methylfolate. Why do we remember some things and not others? Think about your daily commute to work, for example, or a trip to the grocery store. This simple trip that you take all the time requires the activity of millions of neurons in your brain. But you would be hard-pressed to remember what was happening halfway to your destination during your commute last Thursday. So how is it that millions of neurons could be activated during this commute without storing this information in your brain? Two Northwestern University researchers may have the answer. Looking into the brains of living animals, the team discovered signals in dendrites that could explain learning and memory. In your hippocampus are hundreds of thousands of place cells, which are neurons essential for your brain's GPS system. The scientists found that dendrites are not always activated when the cell body is activated in the neuron. Signals produced in the dendrites are used to store information, and signals in the neuron's cell body are used to compute and transmit but not store information. Disruption to the brain's GPS system in the hippocampus is one of the first symptoms of Alzheimer's disease, and why many patients are unable to find their way home. Their dendrites are not storing the information. Dendrites are like branches projecting out of neurons that act like an antenna. Dendrites receive electrical signals sent by the synapses of neighboring neuron axons. You can have as many as 15,000 dendrites projecting from a single neuron. When you experience incoming stimuli from your senses, neuron activity increases, and dendritic spines change size, shape, and conduction, leading to long-term potentiation. This change in dendritic spines, or neuroplasticity, and long-term potentiation plays a fundamental role in learning and memory. The structure and branching of a neuron's dendrites, as well as voltage-gated conductance in the cell body, tells a neuron what to do based on input from other neurons. But dendrites are not passive participants in this chat between neurons. Voltage changes at a particular location on a dendrite transmit the electrical signal through a system of dendrite elements, including different diameters, lengths, and electrical properties. Now, we'll dig into these neuron electrical properties in more depth later in this video because they're crucial to how memories are formed and which nootropics do what to influence these electrical signals to boost cognition and mood. Now, nootropics to boost dendrite health include ashwagandha, artichoke extract, DHA, gotu kola, and turmeric. Each neuron in your brain can have thousands of dendrites, but only one axon. The neuron uses its axon to transmit an action potential, or an electrochemical signal, down the length of the axon, with the intent of finding neighboring neurons' dendrites to communicate with. The nootropic factor, nerve growth factor, brain-derived nootropic factor, and neurotropin-3 are involved in axon development. Now, I've got an article called 13 Nootropics to Boost BDNF. And I believe that video is here on this channel, as well as I'll provide a link below this video to the article on Nootropics Expert. When the action potential reaches a presynaptic terminal, or the tip of the axon, it activates the synaptic transmission process. The first step is opening calcium ion channels in the axon, allowing calcium ions to flow across the axon. This increase in calcium concentration causes vesicles, which are tiny containers enclosed by a lipid membrane, filled with a neurotransmitter, to fuse with the axon's membrane and empty their contents into the extracellular or outside space. The neurotransmitter diffuses across the synapse to receptors located on dendrites of the target cell. The neurotransmitter binds to these receptors and activates them. Depending on the type of receptors activated, the effect on the target cell can be to excite the target cell, inhibit it, or alter its metabolism. This entire process takes less than 1/1000th of a second. The presynaptic axon terminal then moves a new set of vesicles into position, ready for release when the next action potential arrives. This process of communication between neurons and axons and dendrites is how memories are formed and affects alertness, concentration, cognition, and mood. Use the nootropics ashwagandha, gotu kola, vitamin B1 or thiamine, vitamin B6 or peroxidine, and vitamin B12 or methylcobalamin to maintain axon health in your brain. The basic mechanisms involved in neuroplasticity include neurogenesis, dendrites and axons, cell death or apoptosis, and synaptic plasticity. Repetitive stimulation of synapses can result in long-term potentiation or long-term depression of neurotransmission. Together, these changes are associated with physical changes in dendritic spines and neuronal circuits that influence your behavior, memory, and mood. Neuroplasticity is most active during childhood, but remains with us into adulthood. Researchers have measured and studied neuroplasticity in human brains for decades, and it's the basis behind how and why many nootropics work to boost memory. Neuroplasticity was identified back in 1949 by Donald Hebb in his book Organization of Behavior, a neuropsychological theory. Hebb's theory was that your brain adapts to its environment based on experience and development. Thinking and learning change your brain's physical structure and functional organization. Hebb was the only guy who coined the term so often quoted in nootropic circles, neurons that fire together, wire together. Nearly all the nootropics in our big list of nootropics influence neuroplasticity. But you can boost neuroplasticity in other ways as well. One study at Emory University worked with 13 regular practitioners of Zen meditation and 13 matched controls. This study examined how the regular practice of meditation affected the normal age-related cognitive decline of gray matter in the brain. The study found that Zen meditators did not experience any significant reduction in gray matter, but the non-meditators showed the expected loss of gray matter and the loss of attentional performance. Neuroscientist Richard Davidson of the University of Wisconsin led experiments with the Dalai Lama on the effects of meditation on the brain. The study showed that meditation practice results in different brain activity levels associated with attention, anxiety, depression, fear, anger, and even the ability of the body to heal itself. The study concluded these functional changes resulting from meditation can be caused by changes in the physical structure of the brain. Now, for more on how your meditation practice can be enhanced with nootropic supplements, see my video on Boost Nootropics to enhance meditation and calm your mind. Aerobic exercise boosts adult neurogenesis by increasing the production of brain-derived nootropic factor, or BDNF, insulin-like growth factor, and vascular endothelial growth factor. Neurogenesis in the hippocampus from exercise is associated with better spatial memory, and consistent aerobic exercise over several months significantly boosts executive function and increased gray matter volume in the prefrontal cortex and hippocampus. Studies on ADHD patients using MRIs suggest that long-term treatment of ADHD with stimulants like amphetamines or methylphenidate decreases abnormalities in brain structure and function, and improves neuroplasticity in several parts of the brain. Studies with ADHD stimulants with normal adult brains, or people not being treated for ADHD, showed mixed results. Some studies showed ADHD stimulants reduced neuroplasticity in the healthy adult brain. Since this is about nootropics and how supplements work to help boost memory, we'll not delve too far into the neuroscience of which part of your brain does what. Instead, we'll dig down into the cellular level to explore how nootropics influence brain function and what you can do to improve memory. We now know that thousands of neurons, dendrites, axons, neurotransmitters, action potentials, neuroplasticity, and growth factors all contribute to the formation of memories. And we reviewed many of the nootropic supplements that can assist each of these. But to really understand how memories are formed and recalled, we need to dig even further, all the way down to the molecular level. Now this can be a little intense, so stay with me here. There are basic steps in the molecular biology of short-term memory and its conversion to long-term memory for both implicit and explicit memory, or procedural and declarative memory. Procedural or implicit memory is long-term memory that is responsible for motor skills and knowing how to do things. Things like talking, walking, and driving your car. Declarative or explicit memory is long-term memory that includes episodic memory, your store of people, places, and objects, and synaptic memory, your store of facts and events. When new information comes in from your senses, short-term memory uses existing proteins and neurons. Short-term memory lasts from 20 to 30 seconds, but its conversion to long-term memory requires new proteins to be created via gene expression, or new microRNAs and protein synthesis, and long-term memory can last from a few hours to a lifetime. Incoming stimulus from your senses to your brain stimulates the release of serotonin. Serotonin binds two types of receptors on the neuron. One is coupled to the diglyceride protein kinase C system, and the other is coupled to the CAMP protein kinase A system, and both are signaling pathways. These protein kinases exert two types of actions. First, they regulate the properties of membrane channels in the presynaptic neuron. This action regulates the amount of calcium that enters the synaptic terminal during an action potential and causes a boost in the release of the neurotransmitter, leading to an increase in the excitability of the postsynaptic neuron. Second, kinases regulate the cellular process involved in neurotransmitter release, including the pool of available synaptic vesicles available for the release in response to the incoming calcium ions with each action potential. And finally, serotonin leads to changes in the properties of the postsynaptic neuron. including an increase in the number of glutamate receptors. Now, I hope I haven't melted your brain yet. Just know that the consequences of these processes determine the strength of the synaptic connections and your ability to form even short-term memories, like knowing you better stay out of the way of that guy running a stop sign, or that fork full of salad goes in your mouth and not in your ear. And one more thing. Learning involves the engagement of second messenger systems. This is where protein kinase C and protein kinase A come in, and CAMP is one of the critical second messengers involved in memory. There seems to be a lot going on here just to form short-term memories, but they're short because all of the above processes are very transient. The duration of these memories is dependent on how long the various proteins and membrane channels are phosphorylated. Now, PKA, or protein kinase A, will only be activated for a short time after a brief stimulus because cyclic AMP, or CAMP, will be degraded and PKA levels will decrease. Protein phosphatase will remove the phosphate groups on the proteins that are storing these short-term memories. Now, you need the ability to form short-term memories to form long-term memories. Short-term memory can be increased with the nootropics, Huperzine-A, Kava, Rhodiola rosea, Phosphatidylserine, CDP-Choline, Bacopa Monnieri, and Nicotine. Now, earlier I touched on the two major differences between short-term memory and long-term memory. Long-term memory requires new protein synthesis and gene regulation and expression, and short-term memories do not. And long-term memories typically involve physical modifications in your brain, otherwise known as neuroplasticity. Long-term memory relies on long-term potentiation, which is the strengthening of synapses between neurons resulting from repeated activity in the brain. Neurons that fire together wire together. Think of reading or listening to this last sentence 5 or 6 times so you'll remember it. And you've started long-term potentiation to create the memory of this sentence long-term. Long-term potentiation comes in 2 forms. There's early long-term potentiation, which lasts from 1 to 3 hours, and there's late long-term potentiation, which lasts 6 to 10 hours. CAMP, one of the second messengers involved in short-term memory, is also involved in producing long-term memory. CAMP affects the membrane channels like in short-term memory. But in long-term memory, CAMP with PKA also phosphorylates or introduces a phosphate group, transcription factors like CAMP responsive element binding protein, or CREB. Transcription factors such as CREB, once a phosphate group is added, leads to gene expression, which leads to changes in expression of proteins needed for producing and maintaining changes in synaptic strength and long-term memory. Multiple genes in transcription factors acting synergistically in a single neuron are involved in the production and the maintenance of memory. Properties of the neuron, the strength of synapses, and gene expression occur at different phases of the memory development. Some occur early, and some up to a day after learning takes place. NMDA glutamate receptors are involved in long-term potentiation with synapses in your hippocampus. Postsynaptic spines on CA1 neurons have 2 types of glutamate receptors: NMDA-type glutamate receptors and AMPA-type glutamate receptors. Both types of receptors respond to sodium ions and potassium ions. But the NMDA receptor is also responsive to calcium ions and can be blocked by magnesium ions. When the NMDA receptor is activated by an electrical signal from a neighboring neuron, calcium ions enter that neuron and stimulate calcium/calmodulin-dependent protein kinase 2, or CAMK2. CAMK2 regulates neurotransmitter synthesis and release. It modulates ion channel activity, gene expression and is critical to learning and memory. CAM2 also makes AMPA receptors more active and recruits more AMPA receptors to the synaptic cleft, which strengthens early long-term memory or early long-term potentiation and helps form short-term memories. Recent research has shown that AMPA-key nootropics like Aniracetam, Coluracetam, Noopept, Oxiracetam, Paracetam, and Resveratrol can increase synapse response and enhance long-term potentiation. Activation of NMDA receptors also results in an influx of calcium at the synaptic cleft. Repeated influxes of these signals activate the proteins Ras-specific guanine nucleotide releasing factor 2 and Ras-specific guanine nucleotide releasing factor 1, which stimulates the reticular activating system, or RAS, and the extracellular signal regulating kinases, or ERK. ERK integrates many signals in your brain, and if ERK is blocked, long-term memory is inhibited. You can use the nootropic Turmeric to activate ERK. RAS can also be activated by BDNF, or brain-derived nootropic factor. Now, we already discussed how to boost BDNF in the Axons and memory section earlier in this video. And in long-term potentiation, the RAS/ERK pathway combines with the CAMP/PKA pathway to activate CAMP response element binding protein, or CREB, which causes gene transcription activity in the neuron's nucleus and creates more permanent strengthening of neuronal networks. Now, you can use the nootropics PQQ and Pterostilbene to help boost CREB. CAMP is degraded by the PDE4 enzyme. Now, if you inhibit PDE4, you increase the duration of CREB's activity by prolonging CAMP's activation of CREB via PKA. You can inhibit PDE4 with resveratrol, oat straw, and artichoke extract. And you can increase CAMP with forskolin and vinpocetine. Artichoke extract and forskolin are key ingredients in the Siltep stack. And finally, Resveratrol has been shown to increase the amount of time calcium channels in neurons remain open. Tied to protein kinase A and the G-alpha unit protein, signaling is enhanced in the neuroreceptor independent of the synapse. This calcium channel pathway is critical for long-term potentiation and the formation of long-term memories. Resveratrol also potentiates protein kinase C-alpha, which is involved in long-term potentiation. Protein kinase C-alpha is dependent on glutamate signaling. And Resveratrol activates the CAMK2, which is critical in memory formation, again dependent on glutamate signaling. Memory touches every aspect of your life, your heart beating to remembering your anniversary to making sure you pick up milk on the way home. Armed with the right knowledge and the willingness to experiment, you can put together a nootropic stack to help improve your memory. Now, just one word of caution. Please do not attempt to use every single nootropic that I mentioned in this video. Take care in assembling your nootropic stack to include at most one from each section. Nootropic supplements work in synergy. So carefully read through each detailed review that I've written on the nootropics that you want to try. You can see the video here for each of these supplements on this channel, or you can read the article over on Nootropics Expert. And finally, it was not my intention to overwhelm you with all the information in this video, but I couldn't find all this information in one place anywhere else. So if you found this useful, please share this video with anyone who could use some help with their memory. And if you have any questions or suggestions, please use the comments section below this video. So that's my report on the best nootropics for learning and memory. If you want to see links to the nootropic supplements and clinical studies I talked about, go to nootropicsexpert.com and search for learning and memory, or click on the link below this video. There you'll find a full transcript of this video. You'll also find dozens of articles on all the most popular nootropics on Nootropics Expert. And if you have any questions or you want to share your experience using nootropics for learning and memory, please use the comment section below this video or at the bottom of my Learning and Memory article on Nootropics Expert. I do my best to respond to comments and questions as quickly as I can. And if you haven't already, download your free copy of Secrets of the Optimized Brain. It's nearly 100 pages and contains details on 92 of the most popular nootropics used today. And consider getting a copy of my book, Head First, The Complete Guide to Healing and Optimizing Your Brain with Nootropic Supplements. Head First is nearly 600 pages, and it's the best guide on the planet for fixing and optimizing your brain. Now, if you could use some personal help with choosing the right nootropics or figuring out how to deal with your own brain health issues, consider booking a personal consultation with me. You'll find a link to my calendar below this video. And if you want to see more videos on all the best nootropics used today, subscribe to this channel before you leave. I'll be putting up new videos on nootropics and optimizing your brain every week. I'm David Toman, author of Nootropics Expert.